So this is a digital display. It tells you your room temperature. It'll tell you your set point over here, tell you your fan speed here, tell you whether you're in heating or cooling mode. It does have a manual on-off switch. If they don't have these locked out, anybody can come by and push that and it'll either turn it on or off. So that's something you might want to look at, is maybe looking at getting these locked out. There's a way to go in here and program them out.
So here's where the rub's going to come. The HVAC guy this morning, we missed this, or he missed it, if you will, and that they don't program that. He programs that.
The HVAC guy?
Yeah, the Daikin.
Well, when we asked him about those, he said the JCI guy will do those.
See, and that's where.
See, and where it comes into is the sheet metal guy. The sheet metal guy buys the stats, the Daikin units, the condensing units. He hires another third party to come in and we wire it.
You plug them in, yeah.
And they hire a third party to come in and do the startup on them.
But there's actually programming on these where the guest, like Darwin's saying, could turn it on, but we can also tell it that when we turn it, they turn it down to 68, it'll only go to 72, but that's programmed in that, not in his stuff.
So we have to have him.
So we're going to have to do some more because that got missed. So we'll catch that, and we'll probably need to film it again because
I'll be back Wednesday.
Yep. So.
Oh yeah, there's another stuff.
So we're in the men's bathroom on the second floor. This is another one of the Daikin units. It feeds the men's and women's bathroom. The main controller for it is located in the men's bathroom.
And then the unit will be up above us.
Yep, the unit's up in the attic space. There's another Daikin stat located in this kitchen prep room on second floor. If you want to turn around behind, you'll get a good shot of the condensing units that are setting out on the roof. The first two on this end are the Daikin units, and the third one on the far end is for fan coil 9. Again, on second floor in the main lobby area, just coming up from the steps downstairs, we have another Daikin stat, and it just does this lobby area or hallway area. So we're in the registration area, and you'll see the temperature sensor back here on the wall. That has a dial adjustment to set the temperature. That sets the temperature for the lobby area. So that'll give us our set point. And then around the corner from the registration area, we have the stainless steel plate on the wall. It does have Johnson controls on it. This is where we're actually sensing the temperature of the space. Okay. So this is a space temperature sensor. The other one that we just shot is how we set the set point. So we're in the map room, and we're back here by the beverage dispenser. So this thermostat here controls fan coil 8. Fan coil 8 is the one that does heating only in the map area. The reason these stats, these are Johnson control stats. Those other stats we looked at were Daikin stats. So we didn't supply those other stats, they came with the units. This is a standard Johnson control stat. If you look on the display, this will display the actual room temperature. If you actually turn the dial, it'll start flashing, and that'll be your actual room set point. So you can turn this dial to set your set point, and then that's what it'll try and control to. So these are a standard JCI thermostat. This is what will be tied back to our controllers, our FEC controllers.
Why not the other kind of thermostat?
What kind? The Daikin?
Yeah.
Daikins are a communicating stat that just communicate with the Daikin. They have a 2-wire, and that's all they do. It's a communication. It's a different communication than what these do. Okay. So you can only use those Daikin stats with the Daikin units. All right, so here we have a typical TEC Johnson control thermostat. So on this project, these thermostats are controlling the fin tube on the wall. So these just control those valves on there. So as the temperature drops in the room, it'll start modulating that heating valve to maintain set point. These have our trunk coming to them so that we can actually read these points and pull them onto the front end. So you have a trunk wire coming in and coming out of here. You've got 24-volt power coming in here to power up the stat, and then you have a 3-wire going over to the control valve to modulate it.
And if you have to change the stat out, what's the process?
You'd have to pull the cover off, you'd have to pull the back plate off, unwire the wires, and wire them to the new one and reinstall one. But the other thing that you would have to remember to do is, since it is on our trunk, It has to be addressed the same as what the one was you took off here.
Just like a smoke alarm.
Or,
Just like a smoke alarm.
or it will drop the trunk out for the whole building. So the other question that was brought up was on the other thermostats. So this is going to be typical of all of the fin tube in the entryways and exterior walls. The last thermostat that we saw in the map room is going to be typical for any unit that we're using an FEC controller on, which would be fan coil 7, fan coil 8, fan coil 9, and the radiant floor. So we're in the vestibule area. So this is the area that has the radiant floor heat in the slab out here. This is the stat that controls the temperature out here. Again, this is the same thing. You have your room temperature. If you turn the dial, it gives you your set point. When it's flashing, you can adjust it. And then this goes downstairs and it turns the pump on a call for heat, and then it'll modulate that three-way valve for the heat out here in the floor slab. So we're in the gift shop. This is fed by fan coil 9. So this is the location of the thermostat, and this will do heating and cooling in this space. So this is the location of the TEC controller, which controls the baseboard heat in the back over here. Again, these are addressed, so you want to make sure that if you replace a stat, they have the current address in them, or it will take the trunk down. There's also an access door around the corner to get up into the ceiling up here to get to equipment above the bathrooms. So this is the NAE for the Mammoth Hotel project. So this particular controller, everything else comes to it. We have logic in here. We're able to put this on the trunk, the network, which is your guys' green line here. You'll notice that that's plugged directly into the unit. IT department does not like switches in here. So the only time we use the switch is we let the IT department know that we're going to be here. We disconnect this, plug this unit into here, and then we can plug our laptop into here. That's why we leave the switches in there. So always make sure that the IT department's cable is plugged in there by itself. This is our trunk wire. You'll notice that most of our trunk is a blue wire. We try to differentiate with the rest of the wire by having a blue trunk wire. These do have batteries in them. They're just a small battery. They do recommend at least every 3 years to change these batteries out. These batteries are not for power outage usage. The purpose of these batteries are to give the unit a controlled shutdown. So it's similar to a computer. If you lose power, you usually have a backup on there for like 5 minutes or something, so it can do a controlled shutdown. That's the purpose of these batteries. The power supply that's plugged in here feeds the switch down here. There is a rocker switch up here behind this power. I don't know if you can see this little red rocker switch back here. But if you shut that off, that'll kill the power to the controller. The controller won't shut off right away. It'll go through a controlled shutdown, and then after like a minute or so, it'll shut down and the lights will shut off. Okay. We also have a transformer reset. So if for some reason a wire gets shorted out or there's too much amperage draw or something, there is a reset here to protect the controller.
So no lights, no power, check those things. And
Correct.
normal lights should be the
Yeah, and these lights should be green like this flashing.
power is kind of the FC bus.
You'll also see on here,
Your
right up
network
here,
link.
you have a battery fault. So if you have an issue with the battery, this will turn red. You'll want to replace it before then, but at least at that time. And then you have a red fault light that'll come on here if there's a fault.
So green is good, red is a bad thing.
Correct. You got it. Okay, so that's the main brains. So everything else that we're going to show you comes in and connects to these FC trunks. So we're going to start over here. This is the heating system panel. So this will take care of the hydronic hot water pumps, the VFDs, the heat exchanger valves, all of the sensors. And all of those points are wired in down here and up here. The bottom are inputs, The tops are outputs. We were talking about addressing the TECs earlier. We have the same thing with these controllers. These have to be addressed correctly or it'll take the trunk down. With these particular units, there's dip switches here where the white switches on the red background. That's how we address them. Something not to get confused is we have FECs and we have IOMs. FECs are field equipment controllers. These have logic in them. These are IOMs. These are input-output modules. This unit tells this one what to do. These units are connected to this unit through this brown plug, which is an SA bus. This is different than the blue plug, which is our field trunk. The field trunk daisy chains to all the systems that have brains. The brown SA ties these IOMs into our FEC controllers. And all of our thermostats that we went through, like the ones in the administration office, the fan coil 9 in the gift shop, they all daisy chain back into this FC bus also.
So this is telling the VFDs what speed to run at, but the calculations for what speed to run at are coming out of FEC.
Correct. And it's the same thing with our VFDs over here. They are also connected. So you've got the pump VFDs here and here. These are also connected back to that heating controller through the SA bus. So we're able to pull in a lot more points that way with it.
So we can look at amperage loads.
Correct. Correct. Something else to keep in mind here, again, you have your rocker switch up here. There is auxiliary power outlets on the side here. If you kill this switch, that just kills the 24 volt. These outlets will stay hot unless you find the breaker and kill the breaker. Okay?
So would there be an occasion where you'd ask us to remotely repower those?
Yes.
Then this is how we do it.
Correct. I'm just going to have you shut that off, wait till all the lights go dead, and then I'll have you turn it back on.
So it's like rebooting a computer. So if you say, hey, go ahead and
Direct TV, turn it off, turn it on, back on.
Yep.
So another thing, just, you know, for troubleshooting purposes, if you come down here and these lights are on, if this one's dead, there's nothing to it, you'll notice there's two transformers here. We usually pull one off each transformer. Check these reset buttons. Okay? So all the sensors, so our temperature sensors that we have on the heat exchangers over here on the hot water system, all the signals going out to the steam valves, all come out of here, off this heating system controllers.
So the outdoor temperature sensors coming back to that also.
Yes, I believe that's what we were looking at on the point schedule upstairs, yes. I believe it was input 1 right here. So this is the controller for the radiant in the entryway. We'll go down this corridor and we'll show you where the equipment's located too, and the differential pressure sensor off here. So this one has a thermostat coming in here, our trunks daisy chain through here. Then we have our inputs and outputs for a supply fan command, supply fan status, and then we have a temperature sensor, and then we have the output going to the three-way mixing valve. Again, panel, same thing. You have your shutoffs up here, your resets right here. So this FEC controller is for the exhaust fans. This FEC is for fan coil 9, which is above our heads. You can also see up here the heating valves, the blue one. You can see the indicator up there for the position of the valve. There's also a relay on top of that box, and that would be our standard rib relay with the red light to tell you when it's enabled. That's going to be typical of anything that we're commanding. Again, you'll have your inputs and outputs. Inputs on the bottom, outputs on the top.
Have this on those.
Yeah. Yeah.
Is that breaker?
Yeah, so we'll tell you, we'll get prints and stuff.
So down here, this is the Daikin BACnet interface. So this orange cable is the network cable from the IT department. This wire here is the 2-wire that goes all the way up to the 3rd unit on that balcony on the 2nd floor. And this is a 24-volt power that comes out of this NAE panel. So this is how we're able to pull in points from the Daikin system into the front end of the Metasys system. This gives you the IP addresses, the subnet, and the gateway of the addressing that's been programmed in here. 500 amp transformer. It's broke out into 5 100 amps. So we use this for our 24-volt power going to the TEC controllers and any remote FEC controllers. So like all those TECs going for the H1 through H8 through that radiant heat, those all require 24 volts. So we try to put an average of 5 of them on the circuit. So something to keep in mind, the lights are lit down here, the ones that are turned on. You have an on-off switch here, so if you need to work on them, you can kill the power there individually without taking the whole building down. There's also resets right here if they trip. So if somebody's wiring on one and shorted out when they're doing something, you can come back down here and reset them.
So if there's,
So either of the two kinds of thermostats are getting their power out of there.
The TEC thermostats would be getting them from there. The Johnson Control ones, like in the
Gift shop.
gift shop, is getting it off the SA bus.
That's
Yes.
9. And the power to control on the radiance, the solenoid valves.
Comes in. So there was a question brought up on the steam valves, how to differentiate between the 1/3 and the 2/3 valves. The 1/3 valve is the smaller valve, so that's the one that has a single actuator on it. The 2/3 valve is a bigger valve, so that's the one that has the double actuator on it to move the stem on the valve. So if you look at 1/3 has 1 actuator, 2/3 has 2. And that'll be typical of both heat exchangers. Okay, so we're on fan coil 8 in the crawl space. If you swing over to the left here, you'll see this 12 by 12 electrical box. And that's where the FEC controller is located that controls this unit. So we have our trunk coming into here, our SA bus from the thermostat, the power wire and everything comes into that box, and the controller's mounted in there, and then the wires go to the unit. And that'll be typical of fan coil 7 also. So we're filming the location in the crawl space for the hot water differential pressure sensor. And by sensing the differential pressure here, that's what controls the speed of our hot water pumps. So this is straight across the corridor from fan coil 8. All right, so we're going to start by going over the different layouts of the individual systems for this project. First thing we're going to go through is our O&M manuals. So this is the actual O&M manual, a copy of what the owners will get. So looking on this, it gives us the project name. This is a JCI project number. So if anyone has an issue or you have questions or you need parts ordered for this, please refer to this number because it makes it a lot easier for us to look it up in our system. So then coming down here, we've got a drawing index that shows us all the different pages that are back in here. So for instance, if I wanted to go to the fan coil flow layouts, I'd go to diagram 4001, and then I would literally page back to the 4001 page, which is shown in the right-hand corner, and then it gives us the flow layout for the fan coils. So I'm just going to start from the beginning of the sheet. We'll walk through. So this is one of the important sheets, or what I consider an important sheet. This is our riser diagram. So all of our controllers that we have in this building, so we have an NAE in the basement. We have these broke up by floor. This is what's located in the basement. These are what's located on the first floor. And then the last of them are up on the second floor or up in the attic space. So every one of these devices communicates with our NAE down in the basement by the means of our field trunk. So this dotted line is a representation of the field trunk. Now, it doesn't necessarily go to this one first and then to this one. It could go over to here, back to here, but it's a representation of what's on the trunk and in what area. So this line connects to every one of our controllers. We'll go through, we do have some TEC thermostats that are located on the different floors. They have an LCD display on them. Those are all connected with the, all right, so our FEC trunk will come off the NAE and then it'll daisy chain to every individual device that we're controlling. Now these devices that our trunk ties to, that's something that we can see on the front end. Okay. So we can pull in points from there, we can command them, and that's what we use to tie our graphics to, okay, is those points that we pull in from there. So we've got these different controllers. We'll point these out as we're going. So we've got one for the hot water system downstairs. We'll go through those panels. We've got the radiant floor in the entryway.
Are you doing a reset schedule on any of these hydronic systems?
We're doing a reset schedule on the water coming out of the steam heat exchangers. Okay. We'll get into that when we get downstairs so we can actually point to it and go through it. Okay. But coming out of the steam heat exchanger, we're doing a reset schedule basically just on the hot water supply going to the building, which... Just
with a three-way bypass or something?
Yeah, we'll look at it downstairs, but we've got two-stage steam valves and stuff like that on it. So we'll go through that after a bit. And then we've got fan coils. So there are... So again, that's the trunk that hits all the devices. We have the two VFDs downstairs on the hot water pumps are also pulled in there so we can see amps and everything off of those also. So this is a handy list to go through because it shows you all the connections. So if you go into a system and part of it's missing, it'll give you an idea where to start looking to where that line's cut at or been damaged at.
And this is all on the program?
These are all, will be in the O&Ms.
Oh, okay.
So you guys will actually get copies of these drawings.
Okay.
Okay?
But as far as figuring out which one is missing?
When you look on the front end, you'll have red X's on the ones that you aren't communicating with.
Okay.
So then you can reference that to the drawing. That'll tell you whether it's between basement and first floor and second floor, or if the whole trunk's down, then you probably have some type of an issue coming off the NAE on it. Okay. So then we'll go to the next page, and this is just happens to be the hot water supply flow layout down in the basement. So coming in on this side, we have the steam going to the two heat exchangers. You have dual heat exchangers downstairs. So we have a steam pressure sensor here that we can measure the steam pressure. If that steam pressure gets too low, it generates an alarm. Okay. Then on
what is that steam pressure best at?
Between
4 and 8?
I believe I have them set at 4 or 3 and 6 is what they're set at. Okay. So then coming into the steam heat exchangers, we have a 1/3, 2/3 valve to each heat exchanger. So you guys are probably familiar with the 1/3, 2/3. 1/3 valve just goes at low flows when there's not much demand on the building. In the winter, when it gets colder out and you get more demand, then it starts modulating that 2/3 valve open also, in order to get enough steam to heat up this water to the 140 set point. Okay.
And we're maintaining a specific set point. We're not resetting based on outside air temperature.
I believe in here we're resetting it by outside air. So I know the top's 140, so the low's usually around 100.
Okay.
So we'll reset it between 100 and 140. Okay? And we'll do that off this heat exchanger hot water leaving water temperature. So those are the sensors that we use to modulate these valves. So if you get an error on these sensors, that's something that'll have to be addressed right away. Okay? These other two on the return side are for monitoring purposes.
Now, those thermistors, do we have some sort of ohms resistance that we can measure them with? Do you have a chart or something?
It is in the O&M manual with the product literature. Okay? Then coming out of there, we've got two hot water VFDs that are going to the two hot water pumps. Okay, so then we'll modulate those pumps based on the system pressure, which is our hot water differential pressure sensor. I'll show you the location of that in the basement also.
Okay.
It's partway down the crawl space.
Okay.
Okay?
And they're running lead lag,
They are.
so both of them normally should not be on at the same time.
Now, the other thing too to keep in mind, speaking of that, is when we went through with the commissioning agent, there is a stage upset point. So if the one pump runs at 95% or higher for more than 5 minutes, it will turn on the leg pump. But if it's down below that 95%, then it'll just run the one pump and maintain the hot water differential pressure.
But in your all's mind, something big should be triggering that full house minus 40 degrees. Something's happening.
Yeah.
Now, we did notice the other day, because this building is also tied into the rooms. So we did notice the other day when we were actually staging these and doing the commissioning on them, that there must have been a demand on there and everything must have been open.
What time of day, do you remember what time?
It was probably about 10 o'clock in the morning.
Yeah.
So I'm guessing that they probably didn't have a whole lot of heat over there because we got the second pump running that morning. And then everything was full load and our differential pressure was down low and it was kicking up, and we were trying to figure out, you know, there was not much load in this building. I mean, you've got fin tube that's probably taking maybe 1 gallon a minute. You've got that radiant floor in the lobby. Trying to remember what else we had. You know, and the steam heat exchangers for heating the water up. And that's pretty much the load on this building. And those pumps were both going at 93% when they actually came up. And it was because of the hotel over there. So we figured everything must have been open, and none of that's on digital, so we can't tell what it's doing at this time.
Well, I know we had people opening up their thermostats on their radiators because they were cold, and then they were complaining that they were too hot because, you know, they're cast iron radiators and they take forever to cool off.
Right, yeah, exactly. We do have hot water supply and hot water return temperature sensors in here too. And the graphics on the front end look pretty much like this here. A little nicer colors, but basically the same layout. Okay. And we'll go through and point out where all those locations are.
Where's the location like for the outdoor air temperature sensor? Is it out on this, you know, trying to figure out what end of the building?
It is out by,
You probably know where that is from.
It's usually on the north side of the building, right?
it's on out by these condensing units. Yep.
Okay. So if we pack it over with snow, like we're gonna do those conditions.
We don't have
So the other thing that can come in handy too is this is our point schedule. So on the boiler system, if you read this line here, controller details, you'll see we have an FEC 2611 and an IOM 4711 that have all the points on there that everything's landed to. Our hot water temperature sensors, our hot water differential pressure sensor, our outdoor air temperature sensor are all landed on these controllers. So this tells you where they're landed on those controllers. So here you have an outside air temperature sensor is landed on universal input 1 on the FEC controller. Okay. We have a pump 1 status is landed on binary input 7 on the FEC controller. So like you were mentioning about resistance on sensors, if you have a bad or a question marks on an outdoor air temperature sensor, you can literally go to the FEC controller, input 1, pull the 2 wires off and do your ohms on it to see if the sensor is bad.
Okay.
So this gives you a nice indication where everything's at on the controllers. The next sheet is our wiring diagram. I'll have to flip back and forth here a little bit. This tells you how the connections are made for each sensor and how they're wired to. So for instance, on an outside air temperature sensor, we'll follow that all the way across here, and it tells you reference detail shape F131. So then you come over here and you find your detail F131 and it gives you the wiring diagram and how they should be terminated. Okay? So that's standard for all those items on that point schedule. They reference the information on this wiring detail sheet.
And some of that can be handy because you're gonna have Darwin on the phone explaining where to go, where to find.
Oh, no, you didn't have to watch Darwin's video.
Yeah.
That's right. That's right.
But that's part of the advantage to being able to get them remote is that we can get sudden service because we can be hands and eyes if we know where he's talking about when he's saying go unhook these terminals and how those are labeled and what have you. So that'll be
So the next system I've got here is the HRV unit. So we have two heat recovery ventilators on the project, HRV1 and HRV2. So HRV1 just does, I call it the map room on the north side up there on the first level.
That's the smaller of the two units.
That's the bigger of the two
bigger.
units.
Okay.
And the second unit is HRV2, and then what it does is it feeds minimum outside air into the ductwork that's coming off the Daikin unit. So like this room will have up above the ceiling, that supply duct will be tied in here to get fresh air into this room. And it's done with all the fan coil units. Okay? So something to keep in mind on the HRV units, there is no heating, there is no cooling on them. They are strictly for fresh air from outside, bringing it into the building and exhausting air out. Okay?
they're designed to take the heat that's all in the air out and temper the air coming back in. It's kind of what they're.
Correct. So a lot of times what they'll end up doing is they will take this return air and they will pull this out of like the bathroom areas, any place where they need to exhaust air from. They'll pull them up through the heat exchanger on the heat recovery unit, and then as that outside air is coming in, it will preheat that air before it comes in and blows down into these rooms.
And where that happens is in that cell he was talking about, that every 5 years or whatever we got to
Wash
pay
it.
attention to.
Okay. So on the heat recovery units, there's a outside air damper and there's an exhaust air damper. It's just kind of important to remember that it's controlled internally from the unit. We're not controlling them. So what we're doing is we're sending an enable to the HRV units. Once it's enabled, it's going to command both of those dampers open. And when the end switches, the dampers open all the way up, the end switches make, then they go back to their respective VFD drive, which is internal to the unit, and it will allow the safety circuit to complete so that the drives can run. Then we're sending a signal to the supply fan and the exhaust fan, and that was set by the test and balance, which they're basically all at 100% on all the units. So basically then we're commanding those fans to 100%, and then they're just doing their thing. Okay. We do have some outside air filter statuses, and we have a return air filter status. And so those can be set so if they get dirty, that they can trigger an alarm on the front end and remind you that it's time to clean the filters.
And that's all manometer based or just pressure differential? Or?
I've got to look at these. These look like they're just a switch.
Okay.
So you'll have to manually, when you get up there and you get ready to change the filters, if they're dirty and you're ready to change them, you'll need to adjust those with a screwdriver until they trip. And then the next time when they get that dirty, and it's based on differential pressure, then it will trigger that alarm.
How many sets of filters did you see in those HRVs today?
Well, there was 4 on each inlet exhaust. So
2 different sets.
2 different sets, yeah.
And those would be because we're going to filter the air we're dragging in from outside before we blow it into the room, and we're going to filter the air we're dragging out of the building before we run it through that. No.
Oh, sorry.
Through the heat exchanger. Yeah. So the exhaust coming out of the return air coming out of the building, you want to filter that so you don't plug the heat exchanger, and then the outside air coming in is filtered so you don't plug it with cotton or whatever.
Right. See, the one up in this attic, I thought he only showed one set of filters, so I wanted to make sure you guys knew there was another set of filters up there on the other side.
Okay, and then we have temperature sensors located on the return air, the discharge air, the exhaust leaving the heat exchanger, and preheat temperatures. So that you have different temperature sensors on the front end, so if somebody ever wants to do calculations to see what it's doing for heat recovery, for efficiency and stuff, you can do that also. Okay, something else I want to mention.
So this whole thing is ×2? Is that the way we?
Correct.
would see that?
Yeah, and you'll see right here it says typical of 2. So there's 2 of them. There's HRV1 and HRV2. Okay. Something else I wanted to point out to you is over here on the upper right-hand corner, we have this bill of materials. So for instance, if I pick this discharge air temperature, so it's labeled DA-T, and you go over here under description, it's DA-T, tells you the quantity and the actual JCI part number. So you can actually get replacement parts right off this bill of material off these O&Ms. So this will list all of the parts on there. And again, this will have a point schedule with it. It'll also have a sequence of operation. So basically, the way we just walked through the sequence of operation, that's all written down here also. So that a month from now, if you don't want to look at the video, you can come back through and read it on the O&M manuals. It'll give you the sequence of operation, how everything's controlled in what order.
No, you can read this off the video. It'll be readable. I can read these charts.
Wow.
Okay, so like I had mentioned, we do have the point schedule and the wiring diagram for the HRVs. So the next pieces of equipment are the fan coil units. So there's some Daikin units, and they are labeled fan coil 1 through fan coil 6 and fan coil 10. I did put a note down here on these final as-built for clarification, because I was a little confused on them. There is also then the ones that we're controlling with some of our Johnson Control controllers, our FEC controllers, is fan coil 7 and 8 and fan coil 9. Okay, fan coil 8 does the map room, fan coil 7 does the gift, or let me rephrase that, fan coil 9 does the gift shop, fan coil 7 does the main entry, and fan coil 8 does the map room again. Okay, little bit different setups on them, and that's why their different drawings are on here. So fan coil 9 that does the gift shop has heating and cooling both on it to cool that area. Fan coils 7 and 8 that does the main lobby once you get into the building and the map room have heating only. Okay, and basically the Daikin units have at this point in time cooling only on them.
So the gift shop fan coil 9 has DX cooling
Correct.
and hydronic
Heating.
has
That is-
hydronic coiling.
That is correct.
Okay. That should be the one that's down in the mechanical.
It is. And the condensing unit that it's
That we were looking at up in the ceiling.
and the condensing unit that's tied to it, it has its own condensing unit. And if we look out these windows out here, it's going to be the furthest one to the right.
It's the Aiken. It's not a Daikin.
Yeah, I forget
For
what,
some reason, we use something else,
right.
just to keep the parts simple. You
So
control it when it's on, how does it,
what we do, we give it an enable to turn it on.
based on your thermostat? There's a thermostat in the gift shop?
That is correct.
So if it's set to auto, and you set it to a temperature, it'll decide whether to run the DX
Or run the hydronic heating, that is correct. Yep.
Oh, then it's run by the temperature control.
There's a temperature
It is.
controller.
It is. We have and if you look at this drawing, let's just look at number 9, which is this unit right here. So here we're using a zone temperature sensor and a set point, which we have a temporary occupied on it. And then we have the hydronic heating coil valve. And then we have the condensing unit up on the roof for cooling. And then we have the command and status on the fan coil unit downstairs. So we're controlling this unit individually. So when we go to occupied, the first thing we do is we turn the fan on. We make sure we have status, and then we look at the room temperature and see how far we're off set point, and then determine whether we just stay in satisfied or we go to heating or cooling. And then we either modulate the heating valve to get to room temperature, or we start staging on the condensing unit for cooling.
And that differential set point from set point is how many degrees as far as?
I'd have to look. Each job's a little different. Normally we have a 4-degree deadband.
Okay.
Okay, so we can get this filled in, because that'll be helpful. What areas are they serving? So we don't have to keep going back to prints all the time. And I'm assuming on your graphics, where you have this graphic, it says gift shop or something.
Correct. It does, yes.
We ought to go ahead and get that in there too, on these pieces. What areas are these 7, 8, and 9s doing?
Okay.
Which will help us later on,
Okay.
because Dean keeps threatening to retire.
Get closer every day.
Me too.
So,
So the gift shop does have cool.
it does, yes.
That was a PC that we were trying to figure out earlier this morning, and we
Yeah.
couldn't find the filters on that unit, so we have no idea where the filters are on that air handler.
Yeah. Tinners didn't know during training? No.
We lost him, he was gone before we nailed him. But we don't see a place for him, so we'll have to check that.
So similarly, we have fan coils 7 and 8 that do the main lobby and the map room, and they just have heating only. So in the map room, they have a thermostat on the wall. It looks the same as the one that's in the gift shop, and it will just turn the unit on, and it will look if it's satisfied or wants cooling. It will just run the fan. If it needs heating, then it will modulate the heating valve to heat the room up to temperature. Now the one in the main lobby area, there's 2 different sensors in there. We have one in the registration area that has the digital display on it, and it has a dial on there that can turn for a set point. Out inside the lobby on the other side of the wall, there's a stainless steel plate sensor. They actually wanted to get the lobby temperature to get a better average of what that lobby is, and then use the set point in behind the registration because they didn't want the public to play with it. Okay, so those are daisy chained in on our SA bus, which is different than our trunk we were talking about earlier. And then we're pulling the temperature in from the stainless steel plate, and we're pulling the set point in from the other temperature sensor in the registration area.
So you could find the lobby cool because somebody put a candle over near the stainless steel plate and a printer under the thermostat in the registration desk, and we're artificially thinking it's
Warmer.
warmer than it is. So those are little things.
And we'll go through and,
Plate, located up high where it can be.
nope, it's located at the same height as the rest of the thermostats in the building. And we'll go through and we'll show you where those are at. Because if you did locate it up higher, you're going to get a false reading on it, yeah. Okay. So we'll just touch on these Daikin units just a little bit. We're basically not controlling anything on the Daikin units. We're pulling the points into the front end so that they can be monitored, and we're generating a few alarms if the temperature gets way off set point. The way the Daikin units work is you have 2 condensing units outside. You have basically a master and a slave, and those are daisy chained together. And then that trunk coming off the master unit goes through and it daisy chains to every one of the Daikin units. Okay? Even the one in the basement in the IT room, that's the end of line downstairs. So that particular unit then also, so you daisy chain to the main cassette unit, which is the one that hangs from the ceiling and blows the air in. And then you also have a Daikin thermostat on the wall, which would be the same as this one over here. Then you have a wire going from those thermostats up to the cassette unit in the ceiling, okay? And those are all 18 two-stranded non-shielded wire. Just FYI, if you have to replace a wire, it's very critical that you use that same wire, okay?
Cassette, do you know where that physically is?
The one downstairs in the IT room is just right up in the ceiling. It's got a grill mounted right to the bottom of it.
No, I'm sorry, I misspoke, I guess. Where all the thermostats are wired back to. They're all wired back to a valve somewhere.
Well, the Daikin units go from the condensing units and they daisy chain to all the cassettes.
Yeah.
Then the cassettes go to each individual thermostat. Then there's a separate wire coming off of the condensing unit outside, the master, to the Daikin backnet interface panel, which is located down in the boiler room or the heat exchanger room. Okay? So what that allows us to do is to plug in a Cat5 cable, and then we're able to pull it through your network and pull it onto our front end to see the points that are available. So zone temperature set points, stuff like that on the Daikin units. We can see status on the indoor fans to see if they're running, and we can see if the condensing units outside are active or inactive. Okay, again, we're not commanding any of that, we're just monitoring. Okay, so that's how the units are wired. So the other thing that we have going on is, I believe right now downstairs, the one in the IT room is set at the master. So whichever one's set as the master is the only one that control whether you're in heating or cooling. Okay? So that room generates heat, so most of the time that unit's going to be in cooling mode. So that means that these units up here can basically cool only if the master's in cooling. Okay?
Wouldn't
So-
that be a bad thing?
Yes, when the winter is cold outside, it's still gonna be the same temperature in that room. Then these can only be in the cooling mode?
Correct.
That's a
Think
problem.
that's a problem?
Not here in Yellowstone. Yeah, that's a real problem.
Again, we're not controlling, we're only monitoring. So if you were talking earlier about what if that room's satisfied and this room's hot. If it's in cooling mode, which it probably will be most of the time, these rooms will try to maintain their individual cooling set points. So if this room needs cooling, it'll turn the fan on and turn the condenser on outside and cool this room, and if the next one's satisfied, it won't do anything. So you do have individual control that way on the different rooms up here.
But not for heating if that one's in the cooling mode,
I don't know you done with that job.
right?
No, I got
Right.
And it's a similar problem we have across the street, so we're working through all that. It's a bigger issue. We bought something, or they bought something, they didn't understand how it really worked.
So again, since we have some,
Yeah, well, I came from one to the other.
so again, since we have Johnson Control controllers on 3 of the fan coils, we have a point schedule and a wiring diagram for them. And then that'll bring us to the next section, which is the radiant panel, which be baseboard heat. So there's like 8 units throughout the building. They're labeled H1 through H8. Those are controlled individually by a TEC controller. And those are the ones that have the LCD bigger screens on them. Okay, so there's 8 of those throughout the building. And those are also part of our backnet, so those points are pulled into the front end. Okay, not a whole lot about those. We're sensing the temperature in the space. If it gets cold, we're turning the valve on. If it gets hot, we're shutting them off. They have an occupied, unoccupied schedule built into them. So they can be adjust there or on the front end. In the vestibule coming in from outside on the front end of the building, there's some radiant in-floor heat in there. So basically we have a three-way valve to let hot water into that slab, and there's a pump that pumps the water through the slab, and we have a temperature sensor on the supply. So we'll modulate to maintain a temperature based on that hot water supply temperature sensor, and we'll modulate the three-way valve. Okay, so as the temperature gets off set point and it calls for heat out there, we'll turn on the pump, we'll open up the three-way valve and inject hot water out into the system to heat it up. Those are located, again, down in that crawl space area, so I'll show you where those are located at.
Yeah, I think that's all.
Yeah, we saw those this morning.
Yeah. Where the ray out. Manifold.
Yeah.
We have 3 exhaust fans that we're monitoring in the building. You have one in the women's bathroom, one in the men's bathroom, and you have one in the ski shop. And those are,
Bathrooms being downstairs or both floors?
it's just the ones downstairs.
And that's the ones going through the heat recovery ventilation units as far as?
Yeah, I haven't really looked at the ductwork, but I'm assuming those and the ones up here are all tied together and they run through the HRV units.